My name is Rahul. I work in the Amazon Partner Network. I work with our partners who are in the category of data and analytics. And joining with me, we have Amit, right, sitting in front of us. And Amit is from Fanatics. And he's going to talk about how Fanatics uses the platforms or builds on top of AWS using their BI solution. So what we're going to do is first quickly do a recap of what are the various options, what are the various choices you guys have in terms of building your BI solution on top of AWS. And the second part in which Amit is going to talk about is how Fanatics actually uses them in principle as a practitioner. What we're not going to talk about today is what these BI solutions can do, what are their features, what are not their features, because I think 1 hour is not good enough for us to cover all of that spectrum. But we definitely want to make sure that all of you are aware in general about the different solution availables, how they work, what are the features of them in terms of running them on AWS. So with that, let's just get started. If you look at running business intelligence on AWS, the first is the Amazon QuickSight, which was just recently launched as GA, and that gives you the first easy to get started. But at the same time, we have an Amazon Big Data Competency Program. And the program is about finding the solutions where we work with the ISV, with this technologies partner, to help validate their solution, to help it integrate with AWS, so that you guys can get started easily. And we will talk about a list of what different integrations are in general. But if you look at it today, we have 6 of the partners listed on the slide here who work with our Big Data Competency Program. So in case if you're just getting started, in case this is the first time you're talking about BI, which I assume not most of you are not, but in case you want to get started, there are a lot of ways you can get started. The QuickSight, which is available to you for your sign up right now, but in addition, you can actually buy softwares from the marketplace also. AWS Marketplace allows you to get the softwares up and running into your own AWS account very quickly. For example, Tableau Server, TIBCO Jaspersoft, and MicroStrategy or Looker. And then managed on AWS MicroStrategy Cloud, for example, Tableau Online, where they actually talked about why they run on AWS, and Chart.io and WingArc first. But not talking about that. Let's just quickly pivot back ourselves to 2 principles, what we talked from the title of the session, which is what does self-service means? What does really self-service implies in terms of it? And what is scalability? What does scalability means when running a BI solution on top of AWS? So if you enumerate quickly on a scalable self-service, if you look at the model of QuickSight, what it provides you, for example, today, you could go up and sign. And for every user you sign, you get additional resources to use. Now, if you are already running a BI tool, which is, as a lot of you may be running today, a BI tool on AWS, then self-service really means in terms of empowering user to create that environment on AWS very quickly and effectively without you being without us being the gatekeeper of that as such. And there are a lot of, as you mentioned, there are a lot of these BI solutions who provide a managed offering on top of AWS, where you can quickly go to their cloud and sign up. But if you look at it from self-managed perspective, there are custom integrations. But more than that, for instance, Tableau provides you, or Tableau recently released with their 10.2 release, ability for you to install Tableau completely using CloudFormation scripts on AWS, which means that if you use those scripts, you can create an environment of a BI tool which gets recreated in the same capacity, in the same way every time you run the CloudFormation script. But or you could go to AWS Marketplace where you could run these softwares and have just one-click experience in terms of how using them. One of the biggest advantage of Marketplace in that context would be that you can run the software for as long as you want, and you can terminate it after that, while using some other services to store your metadata. And from a scalability perspective, there are 3 things you have to consider. First is the classic principle of scaling out, which is that you can do a distributed install or clusters or different services installs, which is generally the pattern. There's a scale-up pattern where you can go and move to bigger instances. For example, if you're running on M3 4XL, you can move to M3 8XL. If you go from M3 to R3, the characteristic changes. The last one is the principle called scale width. And if you look at that scale width principle, that really means is that instead of trying to scale the BI tool itself to do the work, you're leveraging the underlying cluster infrastructure or the underlying infrastructure to do the work for you. For instance, like Redshift, where you are pushing down the work to Redshift, and the result which is getting back to Redshift is only this result set rather than the entire data being transferred out of Redshift. Or Athena, which was announced yesterday, or EMR, or whatever be the underlying data store in that principle. And if you look at really example of what a distributed install is, if you're aware of what a Tableau is, Tableau has multiple components. When you install a Tableau server when you run a Tableau server on a machine, for example, it has 5 components which actually runs in together. There's a background, there's a MySQL database which runs, there's a search part which runs. And if you look at Tableau Online, where they migrated the Tableau, where they provide the infrastructure to you, managed infrastructure to you on AWS, they talk about how they took this infrastructure and broke them apart in a classic micro-architecture kind of pattern, where each of these components runs in a truly elastic manner, again, from a different component. For example, instead of running a MySQL database, you are using RDS. Instead of using own local instance running on the same server of Redis, they are using Elasticache. And all the servers all the processes, different processes are segregated out to different servers. And you can read more about this in this blog on how they took their journey in terms of moving the infrastructure to the cloud. And the last one, scaling the BI tool with the data, that is the part where, for example, Spice provides you the ability to take the data sitting from S3, and it can give you the in-memory access, faster access to the data set, so you can quickly visualize. The same principle in terms of you take to the BI tools, what they talk about is things like either 100% database processing, in-database processing, push-down optimizations. There are multiple ways they can create, they talk about it, where what the terms basically means is that the BI tool is actually pushing the workload to the underlying database to do the work for you. And they are just getting the results set back. So it can use the underlying resources, which can scale very well, to give you the ability to scale much with data as it grows. The second part is where the BI tool takes the data sets, some subset of data sets, create an in-memory aggregate, or create some sort of in-memory representation, which is where things like MicroStrategy cubes, Tableau extracts is where come in, because they take the data set out of the underlying data store, create a in-memory format or create a collab format using which you interact with the data set rather than the underlying data store. And what was we talking about all of this while I was just give you a brief introduction of what are the option availables, how does this work. So now when Amit talks about how they do the work, how do they run the services on AWS, you guys are aware of what are the different choices they have and how they use the choices to make it run effectively on AWS. At the end of it, running a BI tool, as you will learn from Amit later in the session, is that it's not just about using one single data source store, but you can use many of the data stores to do the work effectively. And second, you could leverage multiple integrations. For example, MicroStrategy provides VLDB properties for Redshift, where you can use those properties to customize how MicroStrategy generates, for example, the queries which runs on Redshift. So you get the results set faster and better. And Looker or Chart.io, they support integration with Spark SQL via JDBC or Amazon Aurora for that matter. So you can use those databases also in conjunction with anything else you're using. So with that, I would just like to invite Amit to talk about how they use these tools on top of AWS and what are the features they're using. Thank you, Amit.
Thanks, Rahul. All right, so before we get started, how many of you are sports fans? Awesome, great. So yeah, if you are a sports fan, you certainly would have had a Fanatics experience. I'll give you a little detail about our business. Fanatics runs all the major US sports league sites. If you shop on NFL.com, NBA Store, NHL, pretty much all that is powered by Fanatics. We also own some of the major soccer leagues stores in Europe as well, like Chelsea, Manchester United. So overall, we have about 300 sites, like college and professional team sites, for which we sell their merchandise. And it's pretty interesting. As a Nittany Lion, if I have to buy anything on PSU Store, I go to a Fanatics API-driven site. So with these 300 sites, we actually do complete content design. We bring traffic to those sites. We also do fulfillment, checkout, and then customer support. So pretty much the whole 9 yards we cover for all these 300 sites. And that brings a lot of scale challenges. It also brings a lot of event-driven challenges. So last year, we had about 250 million visitors on our different sites, and we sold 31 million items to them. And that generated almost $1 billion revenue. So we are constantly growing. It's a sizable business, and it's extremely data-driven. I'll give you one example that happened recently, which is in line with what happened with Amazon. So when there was a Cubs game, the Cubs were playing Cleveland Indians, which was the final of the World Series. Of course, we had anticipated that we will see a lot of traffic coming from Midwest. But at that time, we did not have Ohio site running from, Ohio region was not online. Otherwise, we could have shifted our site workload to that so that our business users could have a lot of better latency. And in our business, the latency you remove, the better business you can do. So today, I'll talk about how we operate at scale our BI as well as our site. And we have 3 key focus areas: how we scale our infrastructure on AWS, how we build a lot of analytical content, and then the analytical content is also a lot of event-driven. When we have Super Bowl, we have different kinds of reports running. NFL is also hooking up to our APIs and building reports. When we have Stanley Cup going on, it's a very different kind of work pattern that we see. And then finally, developers. We decided that when we are going to build our infrastructure on AWS, the reason for that was that our developers will not be limited by issues of platform if they don't have enough infrastructure. And we will also build good frameworks and APIs where people who don't even know like programming, they can still do like real-time reporting. So that's how so the foundational thing is the platform that we have built on AWS, the tools that we have picked, and then how we have built productivity for our developers. So as I have been talking about that, our site is very data-driven. We classify our data into business-centric data as well as technology-centric data. And that actually helps us in designing what Amazon service we are going to use. So for example, if it's financials and inventory, we actually use RDS because we have transaction support. When it is customer support, we actually are looking at a lot of customer data in a key value pair store. So we end up using Redis. Then we have technology-centric data, which is, our site is emitting a lot of signals. Our site hardware is actually sending log data. Our site web server, application servers are streaming data to us. So there we actually have stream services which are writing to Hadoop. And of course, we are also using some real-time analytics. So basically, this classification helps us in designing the service and also picking the right BI tool for that. So this is our current data infrastructure on AWS. As you can see, it is also demarcated, whether it is business-centric or it is technology-centric. So our primary EDW is Redshift, which is accessed by multiple ways. Like we use BI tools to access it, Excel, SSRS, Tableau, and MicroStrategy. And then we also have a relational store, which is SQL Server, where we do a lot of transactional reporting. Again, that is considered as business-centric data. And then finally, we have our Hadoop clusters. So if you combine all these 3 things, we have almost a petabyte of data on which we run a lot of reporting, and also we have built a lot of site services which are data-driven. So below, we have our data integration pipeline. We use SSIS still. We use Attunity in cloud. And then we have an interesting thing called Cubole. So I like to talk about Cubole because here is, again, a different design pattern we are using. When people are doing Hadoop MapReduce jobs in Fanatics, every team gets to spin off their own Hadoop clusters. So they are not limited by a monolithic cluster. So if they have the budget, they can just scale up or scale down, and every team can have their own solution. Whatever kinds of analysis they want to do, they can have their own cluster for Hadoop. And also, they can use it for running Pig or Spark jobs. So that's pretty interesting. So now, how we have evolved in last 2 years. In fact, Fanatics had humble beginnings in 1995, and we sold our first online article in 1997. But then, of course, it was constantly evolving. We had our own dinosaur days of reporting on Microsoft Access and Excel. And then in the last 2 years, we decided that we will re-platform everything. And with that, we started leveraging AWS. So we started by building our data warehouse on Redshift. We brought in modern BI tools like Tableau and MicroStrategy. And then we started reporting using Spark and Presto as data sources. And currently, we are doing some real-time reporting using Storm and Kafka and Scala. And then next year, we are poised to do advanced statistical modeling and machine learning on AWS infrastructure. So we have grown significantly on AWS, and it's like this. So now, of course, why we chose AWS? We knew that our business is very complex. Our data volumes are constantly growing, and they will continue to grow. In fact, we purge a lot of data that we store, or we could store. So next year, we are thinking that we will actually double in size. So from 1 petabyte, we'll go up to like 2 petabytes. And with that, we needed elastic storage. And of course, as I said, we have a lot of event-driven reporting. So we also had to scale our infrastructure depending on the scenario. It's a retail business. When we have Thanksgiving, when we have Christmas going on, we add more nodes to our reporting servers. Or to our Redshift, we add more nodes. And then, of course, when the business dies down or it changes, we actually go back and then scale it down. So now let's talk about the BI tools, like the choice of BI tools, because our infrastructure played a big role in deciding what tools are we going to choose. But we also decided that we will do a complete persona analysis. What kind of business users do we have? What data scientists do we have? And then, of course, our engineering users who are using different log analysis tools, who are using Splunk, how could they also leverage these tools? So after doing all that persona analysis, and of course charting it on a spider chart, we decided that if we have MicroStrategy as our enterprise BI tool, we'll be able to cover all kinds of reporting. Because it's a traditional business, and it's also a very modern business. We have agreements with different leagues that we have to send them a lot of reports in their own specific formats in PDF. So for that, we send a lot of almost thousands of reports every day to different leagues. And then we have business users who are running a lot of ad hoc query. They were running it on Redshift, but now they are running it in memory cubes in MicroStrategy. And then we followed that we'll have an object model, the same MicroStrategy cube that we are using to do ad hoc reporting. We can also write services on top of that. And then that could actually stream data back to our customer support representatives. For example, when you call them, your CLV is given to our customer support representatives by a MicroStrategy cube. And then in between, we also had use cases for alerting, because we constantly update our data, and then we need a lot of alerts. Based on those alertings, we can actually run different promotions on our site. So our business is constantly using those alerts that are coming from MicroStrategy. So we also knew that we will need a data discovery tool, because we have data scientists, we have a lot of business users who are very data savvy. And then, of course, we decided that Tableau will be a good choice for that. So what we do is we have a governed Tableau environment where we have limited number of desktop users, and they actually build a Tableau dashboard. And then once the prototype is complete, once business users accept it, then we actually convert that to a MicroStrategy dashboard. As you can see in the screenshot here, both the dashboards are practically identical. It has everything similar what the Tableau dashboard is offering. But the MicroStrategy dashboard, we can, again, run at scale. So that's how we decided that these two tools will cover 95% of our use cases for reporting. So this is our journey with MicroStrategy. 2 years back, I think around February, we decided that we have done enough analysis on paper that we will be using MicroStrategy. But now let's run some experiments, whether MicroStrategy is the tool of our choice or not. So what we did, we took a very small T2 instance on AWS and then deployed a very simple MicroStrategy environment where we had only 10 users. And there we actually built 3 business use cases, which business was clamoring. They really wanted it. One of the use cases was that they wanted alerting, and of course MicroStrategy was supporting that. They wanted to do ad hoc analysis very fast. And then they also wanted to remove a lot of manual workload, because before we started using these BI tools, there were people stitching Excel together. They were really spending 2 days just to get data from multiple systems and building an Excel dashboard and then sending like 300 MB files. So we had to solve those use cases. And that's where we thought that, OK, we will be using the metadata of MicroStrategy to solve these 3 use cases. And once we did our POC, the POC was very successful. And within a month, we were actually in production. So that was the beauty of being on AWS, that from concept to actually production, we could reach just in a month. And then we started bringing different workloads and analyzing that. Based on the workload, we had to find the right hardware for MicroStrategy. So as you can see, within 6 months, we actually moved to a larger MicroStrategy instance. We started using M4 4x large. We had RDS for the metadata. And then within a couple of months, we decided that now we have to migrate to Linux. Windows was not scaling for us. So then we spun off a different instance in AWS, and then we could easily migrate using the same metadata. And now we are using the largest AWS instance, which is like X1. And here we have very large cubes. Like we have cubes with 100 million rows, 300 million rows, and people are using them to drill up and down within predictable SLAs. We know that when they run query on a MicroStrategy cube on this hardware, they will get a response time of 3 to 10 seconds versus waiting on data warehouse for like 30 minutes. So this has been, just because we were on AWS, we could really change things a lot more faster. I remember working, before when I was working, just to upgrade hardware, it used to take us like 3 months. And just to upgrade instances, it used to take 3 years with a lot of IT tickets. And now it's just a 5-minute thing or a 10-minute thing. We can actually go to a different AWS instance and then point our metadata to that. So if you are existing MicroStrategy users, this is our current MicroStrategy architecture. It's a very simplified architecture. I have built very complex architectures with a lot of cluster nodes and all. But now that we are on AWS, we simplified our architecture very significantly. So it runs on one single node. This is production. It runs on a very large node, which is X1. It has 1 terabyte RAM, and it has 8 terabyte of solid-state drives. And that's where we create all the cubes. And it actually can handle up to 500 concurrent web users. We have tested it, and we saw that recently during Black Friday when pretty much every business user was logged into MicroStrategy. So the reason for this simplification was we even put the web server, iServer, everything together, was that we wanted a cloud paradigm. We don't have any MicroStrategy administrator. And same thing, we don't have any Tableau administrator. We have actually built services around our metadata of MicroStrategy and Tableau where everything is automated. When users have to be created, they actually go to a web page, and the users are created. So just because we wanted to make sure that we will never have any administrator, we wanted to simplify everything. And then this infrastructure is connected to different data sources. We have Presto, Elasticsearch, Redshift, SQL Server, and MySQL. All those data sources are using the same iServer, and then business users are very happy with that because they have one single place to go, one web page, where they can find reports from Elasticsearch or they can find report from SQL Server without them scrambling, where is my report? And then, of course, it's connected to the SMTP server, where we can send a lot of large reports. So similarly, just how we scaled on MicroStrategy, we had a same pattern on Tableau. We started assessing Tableau using Tableau Online, and with just 2 desktop users and 5 web users. That was our assessment that whether Tableau is going to be our tool of choice for data discovery or not. And then within a couple of months, we were in production. We started scaling up. But after a certain point, we hit a wall on Tableau Online because it was not giving us the services that we wanted. For example, business users wanted their own ways of data refreshes, and Tableau Online did not have custom schedules for us. So, and there were other limitations as well. And by the time we had come to the conclusion that it's better to own our software be it MicroStrategy or Tableau, instead of going through a managed service. And it's better to leave our hardware on AWS. So that way we had best of both, because we could control our software, which was our intellectual property, and hardware we consider as commodity. So that's why we could always be on AWS. And that's why we started going to that licensing model where we will own the software, and then, of course, we will manage the hardware on AWS. So now let's talk about elasticity and cost, which is all about AWS. As you can see, this is the peak capacity where we distribute the worker nodes of Tableau. So depending upon what is the event, we can actually add more worker nodes or more backgrounders. And then when we have to scale down, then we can actually remove the nodes. And that really helps us in a lot of cost savings. And cost savings is important because what we do is we pick the best hardware on AWS because we don't have like dev environments or QA environments. So whatever savings we get, we actually spend that money on getting the best hardware to support our business users. Our business users are very happy that the hardware we have, we never tell them that you cannot bring in a lot more data. You cannot have a bigger report just because we are limited by infrastructure. So whenever they say, okay, we need even to cache a billion row table, we can do that because we can go to a different hardware grade for that. So in terms of following design patterns, like normally people have dev, QA, and production environments. We actually don't follow that design pattern. For MicroStrategy, we do have a dev instance, but whenever we have to do large QA systems, we actually build it down, and then after the QA is over, we tier it down. That's what we do on AWS. And for Tableau, we have just one production server where we have different folders where we can actually develop and then push it to production. And that's how we manage our environment. So as you can see, this is what we actually use to monitor our cost patterns. This is the cost, like per day cost of AWS hardware for BI, and then of course it is marching in time. When we have higher costs, there could be some event, like when we had to test like disaster recovery. Then we actually scaled up on AWS and built parallel systems. Then we had a lull. Then we decided, okay, now we have to upgrade to Tableau 10. We built a parallel environment, our cost went up. And then we scaled it down. And finally, we brought in a bigger machine for MicroStrategy. That's when our cost went up, and then the MLB finals came. So if you constantly monitor the cost, you can really figure out what is the best hardware or what is the best financial strategy you have. Because sometimes you can sell this as a service as well to your business users. If they need more hardware, they will pay, and we will scale up. So now, let's talk about automation and self-service, because this is important. As I said, we don't have any administrator. What we do is we build services using APIs of MicroStrategy, like Command Manager, Systems Manager. We also have built a same API using Tab Admin and Tab CMD. So this is a different use case. This is actually a triggering mechanism, a URL caller that we have built. What this does is it can trigger any MicroStrategy cube refresh. It can trigger any MicroStrategy distribution service job, or it can trigger a Tableau extract or a Tableau subscription. So the reason was this. When we brought MicroStrategy and Tableau online, then we had data dumps coming from Omniture like every hour. And our business users they always wanted to run, they always wanted fresh data. So what they ended up asking us that, can you refresh my report every hour? And we scheduled it every hour. And we were sending a lot of queries to Redshift. But then, of course, Omniture was not reliable. So we used to miss that window. Sometimes the data was refreshed. Sometimes the data was not refreshed. So then they started asking for, can you refresh the cubes or extracts every 15 minutes? Which means send more queries to Redshift. And at that point, we decided that we had to build some kind of service where ETL, as soon as ETL is done, they know in their workflow that the table is refreshed. They can actually refresh the cube or extract. Now, we know there are legacy ways, like you can always have control tables or you can have touch files. But we had multiple ETL systems. We have Python scripts running, which actually wanted to trigger Tableau, or we had Scala jobs running. So with that, we decided that this service, which will be a URL caller, which will wrap both MicroStrategy and Tableau in a single construct, that we gave to our developers. And we also gave them like flags or parameters that as soon as ETL is done, send email to the business team, and then they will be able to see that their data has refreshed. So this is a way where we use APIs provided by different tools. Similarly, we use another MicroStrategy tool called Systems Manager in a very interesting way. This is an example of scaling up the environment where you can actually add more cluster nodes to the MicroStrategy cluster. But that Systems Manager is a workflow management tool. It can actually copy files. It can actually call commands. It can even run AWS Lambda services if you want to. Or it can call AWS CLI. So we use Systems Manager, again, to automate a lot of administration tasks on both MicroStrategy and Tableau. And that's another way of using these tools more creatively. Now, let's talk about, again, it's cost optimization. In past, where I used to work, we had DR for every BI system. BI is considered like a tier 1 mission-critical system. So we had a lot of idle capacity just for DR. And here at Fanatics, being on AWS, we decided that we will never have any DR. We will actually build machines in different availability zones. So we use US East 1 as our primary zone. But then what we do is we also have AMIs where we actually build machines in a different availability zone. So we have a parallel MicroStrategy environment running in a different availability zone. That's our DR, but it is never running. We just shut down those machines, and that is considered a cold standby. So basically, if we have scenarios where we actually need proper DR, then we turn the machines on for a month, and then that becomes our hot standby. Otherwise, we never spend any money on DR. And now, let's talk about, so over the course of time, our learnings have been that, use whatever AWS offers you. Use cloud formation templates. Use Amazon machine images, because this gives us a very governed environment. If we are using CFTs and we are passing the right AMIs in them, even our developers can spin off machines if they have the rights. And that's what we want. Like, we have complete self-service on the distribution side of reports, but we also have self-service on the infrastructure. People can add or remove nodes depending upon if they're using the CFTs. Then, of course, distribute the workload. We use EFS a lot because in a scenario where we have to move machines from one environment to another, then we have EFS, where all our MicroStrategy cubes are stored. And on the same EFS, we also stored our Tableau metadata dump, just in case if we have to restore it. And then finally, as I said, try to see how you can leverage the CloudWatch or where you have tagged your machines and see how your cost and budgeting is going on. So, as I've discussed, these were the business use cases that we recently solved. We have predictable SLA. We have very scalable environment where we have run tests where even if we have to send 10,000 PDF reports, we can do that. And then, of course, we can use the same metadata for a lot of things. So I will be doing the demo, but this is a simple example of how we have used MicroStrategy APIs to do real-time reporting in custom environments. So we have our ETL running using Kafka and Storm, and then it is dumping into Elasticsearch. And then we have built a MicroStrategy cube, which is actually sucking the data from that. And then we have a custom page that is actually refreshing in real time. So this is very interesting because the same cube that we have used for real-time reporting is also being used for a lot of other things. And here we have used MicroStrategy design patterns, where developers who don't know how to write Java and JavaScript, they can actually consume MicroStrategy widgets, and they can build these real-time web pages without them knowing any programmings. Are we ready for the demo?
Yeah, you can unlock it.
OK. Yeah, so these are two examples I'll show you. This is a MicroStrategy. This is MicroStrategy front end, which we use for financial real-time reporting. because our executives use that, it has to be secure. This is all test data, but the reason for using MicroStrategy for real-time reporting was that we could actually secure it. MicroStrategy has amazing security constructs where half of the people will not see this data. Some of them will see only one graph. We could just secure it by creating security groups in MicroStrategy. So here, this data is coming from this web service. As you can see, hold on, let me refresh this. So this is basically a web service spitting out JSON data. And this is actually running out of a Java transform that we have written. So what it does, it actually makes MicroStrategy xQuery. This actually can be fed to any MicroStrategy xQuery report. So what we do in backend is that transformation service runs, it connects to Redis, or it connects to Elasticsearch, and then transforms the data so that it can be easily consumed in a MicroStrategy xQuery report. And then people can build actually reports using that. So the same data that you're seeing is now available for our developers to use. So let me show you how we make changes. So I'll go to this test reports. Let's see if my session is still there. Sorry. OK. So you're looking at this real-time dashboard that I was just running. So without people knowing any JavaScript programming, they can now easily change it. Like right now, it's a line chart. But if they want to change it to a bar chart, so what they will do is they will go to this test report. And they'll say, OK, I want to edit it. And here we have data sources coming from xQuery. I'll go to properties. And I'll pick the MicroStrategy widget that we have built, which is making JavaScript calls. And I'll say, no, I don't want a line chart. I actually want a combo chart. So I will do line and column, and that will become my combo chart. I'll hit OK. I'll do apply. And now I have a combo chart. So the difference between this MicroStrategy and this is that one was written by programmers. Here, the JavaScript, HTML, CSS programmers are using MicroStrategy API to build custom dashboards where thousands of users can use that. But here, if we have to make any change, then we have to change the style sheet, we have to change the JavaScript. A lot of programming experience is required. But in that dashboard, if no one knows programming, they can still make a dashboard just like this and build in and bring in a lot of real-time widgets. So that's how we have used MicroStrategy APIs to scale our environment. So in conclusion, yeah, so these are the learnings that we finally got. We have based on these 2 years of experience, we figured out that we will have a hybrid ownership model where our hardware will be on AWS, but software will be owned by us. We always go by user-based licenses. We never buy any CPU licenses because we have amazing hardware abilities on AWS. So we can easily predict how many business users we are going to hire, how many contractors are coming in, but we can never predict what kind of workload they are going to throw at either to Redshift or to MicroStrategy. So a CPU-based licensing model actually locks you, where you cannot scale up, even when you have the capabilities of AWS. But if you have a user-based model, then you can just scale up and down depending upon the scenario. Then, of course, use the APIs provided by AWS. There is CLI. Use the API of MicroStrategy and Tableau to automate as much as possible so that you save a lot of administration cost. And then experiment. When we decided that we will go with Tableau and MicroStrategy, we had multiple other BI solutions in sight. So we experimented with them, we deployed them on AWS, ran certain tests, and then we realized that those were point solutions. Some of them could not cache, some of them did not have the security model. So with little testing, we could see that, yeah, this will be the right model that will work for us. And then, of course, we never go with a subscription model. Like we consider software as API. So we don't go with any vendor which is actually subscription-based. We actually own the software, and we own the IP. So with that, time for questions, if you have any.